Hello everyone, I hope you guys are doing great. In this video, we will learn about level order traversal of a binary tree. We will understand the algorithm behind it and implement this question on lead code in C++ and Java. Let's get started. So here is a tree where we have stored some information in the form of nodes that are connected together. This is called root node of a tree, and 5 and 9 are the children of 7. Similarly, 4 and 3 are children of 5. So this is simple, a basic binary tree. Now we need to understand what a level order traversal is. Level order traversal means we want to get the data that has been stored in the tree level wise. What is level? Level is a horizontal line crossing through a tree. So this would be level 0, this would be level 1, this would be level 2. So the information would look like 7, 5, 9, 4, 3, 2. Now we want to store that information into an array or a vector. How do we store that? Level 0's information right here as 7. Level 1's information, there are 2 nodes, so that's why 5 and 9. There are 3 nodes at level 2, 4, 3, 2. So we'll store it in an array, and then we will wrap the whole traversal in one array saying the parent array, or the array that is store all the information of the level. So input being the tree node, the root, we want an output looking like this, or I can write input being tree node star root. We want the output vector of int or 2D array. Right? So how do we go from here to solve this question? Every question of data structure can be solved using algorithm. So now we have to learn what the algorithm behind it. Before deep diving into algorithm, we need to understand what this node look like. It doesn't look like this that we have created. For simplification purposes, I have created this. So the 7 instead look like this. 7, it has data. Then it has some information about what is in the left of this. Something like this. And then what is in the right of this node. Let's say this. So 7 is the data. This is the left node. This is the right node. Left node and right node are nothing but the addresses of the left node and right node. Each data or node would have some address. Let's say 1000, 2000, 3000. Now this left would have the address of the left node, that means 2000. This right would have the address of the right node, that is 3000. So our node actually look like this. If we want to write it in a code or in a structure, we will write it as tree node. It would look like int data, whatever the type of data you want to write, int data, and then tree node star left, tree node star right. So this is how a tree look like in the memory, or when we start doing this question. These are the basic building blocks that we have to know. Now we are given a tree and its root. The output look like this, that is vector of vectors. So what we first create is where we want to store that information. So we want to store that information into vector of vectors. So we will create vector of int. I'll share towards the end of this video Java code as well. So we will write the vector of int, the resultant array. So we will write here as result. The second array is the temporary array, where we have to store the information of each level. Let's say 7, it can be 5 and 9, the temporary array. So that's why we will also create one temporary array saying vector of int, vector v. Now these are the things that we need to start the algorithm. What is the algorithm? We will follow some steps. The first step is create queue. So we will create a queue. Now important question is, what type of queue want to create? What is the data type of that queue? If we create the queue of integer, that is 7, 5, 9, we will not be able to get from one position to the another position, or one level to the another level, because 7 itself doesn't contain any information how to reach to 5. But if we store 1000, it has the information of its left node as well as right node. That means from 1000 we can go to 2000 and 3000. So that's why we will create queue of tree node star instead of the data. So once we have created the queue, the second thing is we have to start from somewhere. What is the place we want to start from? Obviously root, because root is the first element that we're going to store. So that's why we will say now push root into the queue. The third step is push null into the queue. What is this null now? The null is the end of one level. So whenever we are saying we will push null, that means we are saying that this level has ended. Because 7 is already been in the queue, that means 7's level is ended. So that's why we have entered null. So going forward, we will do what? We will follow the steps. What are the steps? We will say while queue is not empty, while there are things in the queue, we will repeat the following steps. What are those steps? 4.1. We will fetch the front element. So we will write front element of queue. We will store the front element of queue. Because its work is done, we will say pop the element from the queue. Because its work is done and we have stored it in the front element. 4.3 would be, we want to make sure what that element is, because we are inserting two types of things in the queue. One is root itself, one is null. One is null data, one is not null. So that means here we need to check if the front element is not null. That means it has some data in it. For example, 7. We are saying that the 7 is there, like not null. In that case, what we're gonna do is we're gonna insert that into our vector v. So if it is not null, we will say insert into vector v, and then b, because it is not null, that means it would have either left or right. So in that case, we will check if left node of that front element exists, we will push it into the queue. If right node exists, we will push that into the queue. Once this is done, then we will understand that the front element can also be null, because we are pushing the null into it. So the else part, that if front element is null, what we're gonna do in this case? We will write, if it is null, we will check. First things first, because the null depicts the end of one level, the end of one level is there, that means it's time to empty this vector v, the temporary vector, into the resultant vector. So we will say transfer vector v or put vector v into the resultant vector. Because v's vector work is done, that means we will just write v dot clear or clear that vector. The c part is if the queue is not still empty, that means there are things in the queue is not empty, we will push null. Now what is this null again? Whenever we encounter null, whenever the queue's output is null, the front element is null, we will check whether the other elements are there in the queue. If yes, that means we have to push another null, because one null depicts the end of the one level. So that's why we'll keep on pushing nulls that shows that this is the end of the level till the queue is not empty. So this is the algorithm that we gonna follow. Now it's okay, like at this point I know 10-20% of the code or 10-20% of this algorithm is understandable, there is not. This is completely fine. We will dry run this, we'll understand how this actually works, then only you will be able to get it. So let's move forward towards the next leg, that is the dry run part. Now we will just follow the algorithm step by step in order to dry run this algorithm and see that how the data would be stored. So where the data we want to store that data into a vector of vector or array list of array list, and then we would have this as a resultant, and then we should also have one temporary vector v that store level wise information. This is done. Now next thing is we'll just follow these steps. So step 1, we will just create one queue of tree node star. So here we have created one queue. Now the next step is we'll push the root into the queue, that is where from where we'll just start. So we will push 1000 into the queue. We have pushed it. Now we will push null. What is null? Null means the end of this level. After root the level has ended. So we will push one null into it. The next is while the queue is not empty, while there are still elements in the queue, we will follow some steps. What are these steps? First of all, we will fetch the front element and we will store that front element into a variable. Right, the front element is 1000 right now, so we'll store it into 1000, and then because it has been stored, its work is done, so we'll remove that 1000. Moving on. Now next part is we will check whether the front element that we just got is actually null or not null, because we are adding two type of information to the queue. So it can be null or not null. In case it is not null, that means it's the actual data we need to store. So we will get its data and put it in vector v, that is storing the level wise information. So we will put its data. What's the data of 1007? So we'll push it into the vector, and then we will again check if it has left 1000 has, yes, it has left 2000. So we will push 2000 into the queue. Is 1000 having any right element? Yes, it has. So we will push that element, that is 3000, into the queue. Its work is done. Now again we will check. 1. We will check the queue. If the queue is empty, no, it is not empty. Step 2. We will check the front element. The front element is null. We will get the front element. We will store it in here saying null. And because it is works done, so we will just remove it. So front element right now is null. In case the front element is null, we will execute 4.4. That means the null has arrived, the level is completed. Once the level is completed, our work is to transfer those level into the resultant vector. So we will transfer this vector v here saying it should be here 7. Next is clear v. That means we should be ready for the another level's results. So we'll clear the v. The third part is if the queue is still not empty, that means there are levels after this. That means we need another null here showing that would be the end of that level. So we'll add the null. Again, step 1, we'll check the queue is empty. No, it is not empty. Fetch the front element. The front element now is 2000. So we'll write the front element is 2000. Now we'll check if the front element is empty or not empty. It is not empty. 4.3. Add its value to the vector v. So we will add 5 here. So a vector v will just update its value, and then we will again check whether 2000s left exist. Yes, it exists. In case it exists, we will push it into the queue. So 4000 is pushed into the queue. Again, we'll check whether 2000s right exists. Yes, it exists. So in that case, we will push that into the queue. So we will push that into the queue as well. So 5000 has been pushed, right? So moving forward, once this is done, we will again check whether the queue is now empty. No, it is still not empty. We will fetch the front element. The front element is 3000 now. The front element is 3000. We will fetch it and pop that element because its work is done. 3000. 3000 is not null. That means we have to store that data into vector v. We'll just push the data into vector v. Now we'll check. 3000s left exist? No. 3000 right exist? Yes. That means it's time to push that data into the queue. After 5000, we will push this 6000. Now 3000's work is done. Moving forward, whether the queue is empty? No, it is still not empty. What we will do? We will get the front element. What is the front element now? It is null. In case it is null, we have to check that this is the end of the level. That means in case null has arrived, that means 5 and 9 are already there in vector v. Hence we need to transfer those information into the resultant vector. So now we will just transfer vector v into the resultant vector, and then we will clear the vector v for the next level's information. Clear vector v. The next we're gonna do is we will again check whether the queue is empty. No, it is still not empty. That means there has to be one more null appended that will help us understand that is the end of the level, because 4000, 5000, 6000 already in the queue, and after that we have inserted null. That means here the level ended. Moving forward, whether the queue is empty? No, it is still not empty. We will fetch the front element 4000 and we'll pop that front element because it is no longer needed. Then we will check if it is null. No, it is not null. In case of not null, we will put its data into vector v. 4000 data v. Put in vector v. 4000 data is 4. Moving forward, then we will check if left or right exists. No, it doesn't. Moving forward, we'll just check if the queue is empty. No, it is still not empty. Now the front element is 5000. It is not null. In case of not null, we will transfer its data into v, that is 3, and then we will check whether 5000 has left or right. No, it doesn't. Its work is done. Again check. Queue is empty. No, it has 6000 in it now. 6000. In case 6000 is not null, then we will transfer its data into vector v, that is 2, and then we will check 6000's left and right. There is no left and right, so we will move further. Now, is the queue empty? No, there is still one null left. So we will remove this null and we will say now the front element is null. In case the front element is null, we will transfer whatever is in the v. into the resultant vector. So we will transfer 4, 3, 2 into the resultant vector, and we will remove all the elements of the V or clear the vector V for the next level. Then we will check if the queue is empty. Yes, now the queue is empty. That means there is no longer need of a null pointer, a null to add in to the queue, because there is no next level. So here it ends. So this is the dry run part of the algorithm. In order to understand it furthermore, take any example of a tree and write down algorithm one side and dry run it. You will be able to understand this code. Now we'll move forward towards the implementation in C++ and Java. We'll write step-by-step code from that algorithm. We need to store the level order traversal in vector of vector. So that's why first we will create that resultant vector. So vector of int result. Then we need another vector, temporary vector, that will have all the information level wise. So that's why we will create another vector int v. Now we follow the algorithm. The first step is we will create the queue of type tree node star, and then the name of the queue, that is queue. The second thing is we will push root into it, because this is where we have to start. After pushing the root, we have to push null, because null represent the end of the level. Then we will do a while loop, that while the queue is not empty, while there are still elements in the queue, what we will do is we will store the front element of the queue. So we will write tree node star front element is equals to queue dot front. Simply we will store the front element. Once the front element is there, we have stored it, we don't need it in the queue, so we will just pop it. So we will write queue dot pop. The next step, we will check if the front element that we just stored is null or not. If it is not, equals to null. If it is not null, then we will try to fill our temporary vector. That means v dot pushback front elements data or value. So we will write the front elements value into the v vector, that is level wise vector. Then after that we will just write if front elements left exist, then we will push it into the queue. So we will push front elements left. If right exist, then we will push the front elements right into queue. Same thing, I'm just writing here. Once that is done, we will move towards the else part. That means what if the front element is null? In that case, we need to transfer whatever we have written in the temporary vector or the level wise information into the resultant array. So we'll write result dot pushback the vector v. Once vector v is pushed back, v's work is done. We'll just clear it for the next level. So v dot clear. The next thing is we will just check if the queue is still not empty. That means there are some other levels need to be handled. In that case, we will push queue dot push null into it in order to understand that there may be next level that needs a null. After doing everything, after coming out of this while, we will just return the result element. So this is how we will write the code. So this is a code in C++ for the same.
There is the Java code equivalent to that algorithm. I will also attach the submission links of the lead code of these questions both in C++ and Java in the description box. Please let me know in case you have any doubts in the comment section, and thank you for watching.